All right, so we'll get things started. So this week, uh, you are still working on your presentations, and we're going to do that on Thursday, right? So you have your partners. So Thursday at noon, we're going to start the presentations, and I'll record those like I am the meeting. Remember that the best way to get any help from me is through Zoom, just like we have right here. Where I can come into your machine and I can see your screen. You can share your screen just like I can share mine with you. But aside from our presentations, hopefully everything's going well with those and you guys have everything that you need. But what I want to address is our next couple of assignments. So I'm going to share my screen with you. And what we are looking at is we are looking at our sheet nesting metal exercise. Oops. Not where I wanted to be. Where are you? I'm going to have to find out where I just put that. The nesting exercise, what's going to happen with that? There it is. So this is the piece that we are going to nest. And nesting is when we take a shape and we try to get as many pieces of that shape onto a piece of material as possible. So if I asked each one of you to take a piece of paper, so if you have a piece of paper with you or anything, and you don't even need to use a pencil, you can use your finger. What I would like for you to do is I would like for you to trace a heart on that, that piece of paper or whatever you have in front of you. So my first question is, doesn't take long, how many of you put that right dead center in the middle of the page? Most of you, right? Because that's just the way your brain thinks. You center it, you put it in the middle. So that would mean that all of the space around that was wasted space. So what we want to try and do is we want to have, for example, here is my nested piece. I want to try to get that up in the corner, and I want to try and twist and piece those pieces in here. I am going to have some strips around the edge. So this would be something we do in like a die. So when we're punching out this part, how many of these pieces can we get out of this piece of paper? So what we're trying to do is you're going to do 3 different layouts. And in those layouts, you're going to calculate your total area. And I've given you the area of our part. Okay, if you use SolidWorks or AutoCAD, I don't care which ones you use, you're going to create 3 different blanks. Okay, and that information is given to you here in your instructions. And we want to see how are you going to rotate those to get the most effective. So how do you figure out, here's your total area, how much area to have in your blank. So let's say that based on my blank here, that I'm using a 3x4 or a 3x6 piece. So if I took my 3 times my 6, that means I have 18 square inches, right? So that's my total area. And then the area of my blanks, I'm going to count out how many of these blanks do I have. And of course, there's my area. So let's say that I only have 1. So then I have my total area is 18. My area of my blanks is 4.4. And that's what's percentage of my scrap. So then I've got to take my 4.0 and divide that into my 18 to figure out what my percentage of scrap is. So the goal here is to minimize the amount of scrap that we have. So taking your area of your part minus your area of your, start that over, the area of your paper or your blank space, take away your part, and what is the final remainder of scrap. That's what we're trying to eliminate. We want to eliminate as much scrap as we possibly can. So you have those 3 different layouts to choose. So here's a couple of examples. So for layout 1, or layout A, layout B, layout C, layout D, do you have to do it these ways? No. okay? But so you can see that between the parts is where our scrap lies. So we're looking to figure out what is it. So here's, again, the formula, how we're going to do that. So our total area in this example is 9 by 5. Our blank area, 1117 or 11.77 times 3, so 35.1. So we take our scrap, 45, minus 35.4, so 9.67 percentage of scrap. So if we multiply that out, we come up to 21.53% scrap out of the parts. Okay. So this is what I'm looking for you to do. Now, I do believe, I go back here, that I have given you the parts as a drawing. So there's the part as a drawing. So you can import that into SolidWorks if you choose. I would probably just use AutoCAD myself because it's the easiest just to rotate, move, and copy. So you've got all the parts that you're going to need to do to take this guy and start moving those in there to get to your calculations and see how you want those to fit in. Does that make sense to everyone? Yes? No?
Yeah.
Good.
Yeah.
All right. I'm going to stop sharing my screen here. So then you also have your fidget spinner that you're going to be doing. So there's the nesting exercise, which it is explained right there, and that's all in the manufacturing materials process. You're going to submit your nesting exercise right below it where it says sheet nesting metal, or sheet metal nesting. And then below that, there's going to be a fidget spinner. Now, you guys, we can't print fidget spinners. And I was looking on my computer, and I think I have it on the computer at school, the actual bearing. So I will send that out to you, and I will put that in the fidget spinner section. Again, I'm going to share my screen with you again. So here where it has the rubric and the instructions, I'm going to add in the bearing for the fidget spinner. So something to keep in mind, when you design your fidget spinners, your fidget spinner needs to be able to be held between your thumb and your middle finger. And the fidget spinners that some of the classes made last year were so big that they wouldn't fit between your hand. So you're going to want to take these, print them out on a piece of paper, and take a look and say, hey, is that going to be the correct size? I'm going to give you the bearings, so you're going to know how big your part needs to be so that the bearing can press fit inside your fidget spinners. But you are going to create your own fidget spinner, and then we can use that. We'll use that fidget spinner again later in 201 next year when we take that class. So that's something we're gonna kind of pile onto for next year. So again, I will put in the bearing. So I'll give you a SolidWorks part file of the bearing. So it'll just be a solid bearing, so you know exactly how big that is, and you're going to create your fidget spinner. So if we look at our rubric for it. Does it meet the specifications, which means it's got to fit inside your hand. It's got to be able to spin. Okay. There won't be any points for the 3D print, obviously, because we can't print it. I'm looking for something different. I don't want just a standard 3D fidget spinner that you're going to go to the gas station and buy. I'd like you to do something creative. And then your functionality. Obviously, I can't grade on functionality because we don't have a print. But again, this is something we're going to use in 201. So we want to make sure that, that we're completing this. Okay. So as far as our construction, now in the past, we've had team members of 2. Well, they're only going to have team members of 1 because you're all at home. So you'll get 3 bearings. Again, I will send you that information. You won't be able to use the calipers, of course, because we don't have them here. So again, just make sure that it's going to fit inside your hand. That you're going to be able to spin it. Now, if you have a 3D fidget spinner at home and you want to use some of the information as far as measurements, feel free, go ahead. Fidget spinners are not something that's new. And, you know, you're probably going to find something out there. If you want to go online and take a look at some and say, hey, I'd like to model mine after one of those, that's fine too. It really doesn't matter to me what your fidget spinner is, but you're going to submit a SolidWorks part file. Now, in the assignment, it says that I want you to submit the fidget spinner. It says, no, I'm looking for 4 files. For you guys, I'm only looking for 3. Because the last one was an STL file, and that's the one I used to print. Obviously, we can't print. So I'm looking for your PDF of your fidget spinner in SolidWorks, and then I'm looking for you to create a drawing. So I want a PDF of the drawing, not a drawing file, but a PDF of the drawing. I'm going to see all the dimensions so that I could actually manufacture your fidget spinner, so I could send it out for quotes. And then I want your actual SolidWorks part file. So I'm looking for 3 files within the fidget spinner project. So you have your sheet metal nesting exercise. You have your fidget spinner that you've got to design and submit. And then, of course, on Thursday, we have our presentations. Does that make sense to everyone?
Yeah.
Yes.
Yeah.
Yep.
Questions about any of that? Anthony, you have a question. You got to unmute yourself, but go ahead.
Is there any chance that you can put what types of files or like what files you wanted us to turn in?
PDF of your SolidWorks part. Create a detailed drawing of your part. Submit as a PDF. Submit your SolidWorks part file.
Sorry,
that work?
I didn't see that.
Yeah, no, you didn't see that because I didn't share my screen for that. But I have in red, submit your STL file for printing, and I wrote not for winter 2020 because obviously we can't do that. I mean, we could, but it won't do anything for us because we can't print. So everything's laid out in there. The only thing that's missing in there right now is the bearing, and I will have that in here in the next 20 minutes, that I'll have that bearings information in there. All right? Maynard, question.
Okay, so do we focus on the nesting exercise in the fidget spinner before the presentation or the other way around?
Doesn't matter. No, these are not going to be before the presentations. These are all going to be before the test. Okay.
Oh, okay.
So I'm looking at probably doing our test next week. So we'll have our presentations on Thursday. On Tuesday we'll meet again just to make sure everybody's got any questions. We'll do an exam review next Tuesday. The test review for manufacturing. You're going to continue to work on your fidget spinners and your nesting exercise, and then we'll take that test later in the week. So really, you have this weekend, most of next week to work on those 2 assignments. David, question.
I'm on one of the school computers, and I tried loading up AutoCAD the other day, and it says it doesn't have like the license for it or something weird.
You didn't borrow a license when you picked it up.
Oh, is there anything I can do about that currently?
The only thing you can do is you have to be on the ISD's network. So I put a video out there that showed you how to borrow a license. Did you see that?
I did not.
I believe it's in the announcements. And I may have not put it in yours. I may have put it into another file. So what I will do is I'll put that in another file. I use that in EG201 for the other cohort. So you would have to be on the ISD's network in order to borrow a license, because basically whenever you start the computer up, it goes to the server and says, okay, I'm approving this computer to work. But you can borrow a license up to 6 months if you're on the network. But you have to be on the network to do it. But for now, what I'll do is I will create a part file for the nesting part so that you can use SolidWorks to do the same thing.
Okay, thank you.
And actually, I believe that in SolidWorks you can import a drawing file. Just a minute, I'm going to try it real fast.
Okay.
But I believe if you're in a it's a little more complicated. What I will do is I will create a SolidWorks part file that you can use. It'll be easier than importing that file. You can do it in SolidWorks, but it's a little more than what we've discussed, and it's going to be a little more difficult for you to do. So I'll create that in SolidWorks. So I'll have the SolidWorks file also, that SolidWorks part file of that part in there as well. Okay?
Okay, thank you.
Any other questions? Cole, what you got?
How have you been doing during the pandemic?
Me, I've been on my computer 12, 13 hours a day. Between the 6 classes that I'm teaching, I have, all of you. You guys have been pretty quiet, but my other classes, they're all face-to-face, and they're not so used to technology that I'm on Zoom a lot. I'm answering a lot of emails. I average probably about 60, 70 emails a day with questions and things. I mean, while we're talking, I just got 4 more from an architecture class that I'm teaching. So it's just nonstop. It seems like I never know when I'm finished or when I'm going to be finished. It's just all of a sudden the day comes to an end. So just so you know my schedule, we decided here at our house that 8 o'clock is our family time. And I have my 2 kids home from college along with my 8th grader. And at 8 o'clock, all technology has to go away, and we do like family game night or movie night. So at 8 o'clock, I quit responding to emails and that sort of thing. But pretty much from 8 o'clock in the morning until 8 o'clock at night, I'm available to you guys for anything that you need. But it's been going around. I've lost, 15 pounds in 3 weeks, so not eating as much, sleeping a lot more, which seems kind of nice, but I'm getting kind of bored. Do a lot of walking and riding my bike when I can. Started gaming, got my TV behind me. They call me One Shot because I'm playing Call of Duty and I kill everybody with one shot. My boys won't admit it, but I'm pretty good.
Whoa, that's impressive.
I'm really not that good, but I keep telling myself I am. I die about 30 times before I can ever get to any checkpoints.
Well, maybe next time you'll die 29 times. Who knows?
It's always a goal. It's always a goal. If I could just tell the computer what to call me. I already beat what was the other one? Medal of Honor, where I was Keegan. That was on the Wii though. So I had to move up to I don't know what this is, an Xbox 360, I think, that I'm on. An old ancient thing, because they've got the PS1 or the PS1 and the whatever the other, but PS1 and Xbox One, that's what they're playing on. But so yeah, it's been pretty good.
Yeah.
Any other questions from anyone? No? All right, I have another meeting that's going to start in 20 minutes. And my family's just starting to walk out of their coffins. So I'll see you guys again on Thursday, 12 o'clock, ready for presentations, right?
Yeah.
Oh, Megan, question.
Yep.
What other medals do you want me to talk about for Ferris and non-Ferris medals?
If you just follow the information from the list that we had online there, so it's just going to tell what are the Ferris medals, what are the non-Ferris medals, and what's the difference between them.
Okay.
Any other questions? No other questions? If you guys got no other questions, then hey, then we're done for today, and we will see you all on Thursday at noon for our presentations. All right. Stay safe. Stay healthy. We'll see you.
Bye.
But